So, what if I told you that there's this one single mathematical tool, kind of like a secret algorithm, that's quietly powering your phone storage, your Netflix recommendations, and even those cool video effects you see online? Well, today we're going to pull back the curtain on this hidden powerhouse. All right, let's start with something I bet you've thought about. Have you ever just looked at your phone and wondered, how on earth can this little device store literally thousands of high-resolution photos without just constantly screaming, "Storage full"? Well, it's all about some seriously clever compression. Just look at this. On the left, you've got the original image. You can think of it as being made up of 638 different mathematical pieces of information. But on the right, we've only kept the 100 most important ones. And to our eyes, they look almost identical, right? But that compressed version, it takes up way, way less space. So the real question is, how does it know which pieces to keep? That secret ingredient, the one behind all this magic, is something called singular value decomposition, or SVD for short. It's basically the mathematical hero of our story today. It finds the most important parts of your data, and that lets our technology work smarter, not harder. Okay, so now that we know its name, let's actually see what this SVD thing can do. We're going to look at a few examples where this algorithm works its magic right in front of us, because, seeing really is believing. First up, let's go back to that image compression we just saw. SVD's superpower here is its ability to shrink an image's size. We're talking its actual byte count, while keeping the quality at a level that's totally acceptable and honestly, often pretty much indistinguishable to our eyes. And here is that trade-off in action. The original image, using all 638 of its components, is perfect. But get this, if we chop that down to just 300 components, we save over half the data, and the quality is still very good. And if we go even further, down to just 100 components, you're saving over 80% of the data for a result that is still incredibly impressive. SVD is what lets us make that smart choice, keeping the essential information and just tossing the rest. All right, let's move on to the next magic trick, removing the background from a video. You've seen this a million times in commercials, on video calls, everywhere. Well, it's SVD that makes it possible to do this automatically. So here's the logic. SVD looks at a video and it sees a really simple repeating pattern. And what's that? It's the background that never changes. It identifies this simple static part as low-rank data. Then it cleanly separates that from the much more complex, always changing data in the foreground, where all the action is. And the result? That clean separation you see right there on the right. And for a last trick, we have the legendary Netflix problem. This was a classic challenge in data science that, for a lot of people, really put SVD on the map. The whole challenge was pretty simple on the surface. How do you get good at recommending movies? Well, SVD tackles this by looking at all the ratings people have already given. It starts to find these hidden connections, little things like maybe you prefer comedies with a certain actor or sci-fi movies from the 80s. It uses these hidden patterns to make a really educated guess, basically predicting what you might like and filling in the millions of blanks in that gigantic rating spreadsheet. So, we've seen what SVD can do, and it is amazing. But what's the actual core idea that connects all of these different applications? Let's go ahead and pull back that curtain. Just think about it for a sec. What's the common thread here? What connects squishing a photo to pulling a person out of a video to suggesting your next favorite TV show? The answer, the big idea, is something called dimensionality reduction. Think of it like this. SVD takes a really messy, complicated set of data. That's what we call high rank, and it simplifies it down into a much cleaner, more basic version, a low rank version, that still keeps all the important stuff. It's kind of like finding the main melody in a really noisy song and just filtering out all the background noise. So how does it actually do this? Let's break it down. We're going to look at how SVD works, but don't worry, this is not about to become a math class. Just think of it as a simple 3-step magic trick. So every piece of data we've been talking about, an image, a video, that ratings table, it can all be represented as a grid of numbers called a matrix. Let's just call it M. SVD tells us that any matrix, M, can be broken down into 3 simpler matrices, U, sigma, and V star. It's basically just a recipe for your that. This really simplifies the whole process. The first step, using that V star matrix, is to just rotate the data. The second step, with the sigma matrix, is to stretch or shrink it along its new angles. And the final step, using matrix U, is to just rotate it one more time. That's it. That's the whole trick. Rotate, scale, rotate. Now, here's the real secret sauce. That middle matrix, sigma, it holds these singular values, and they are perfectly arranged in order, from the most important one all the way down to the least important one. This ordered list is the key to everything. By keeping only the biggest, most important values at the top of the list, we capture the absolute essence of the data while just getting rid of the rest. Okay, so let's wrap this all up by talking about why any of this actually matters. We've kind of gone from some pretty abstract math to some very real, very tangible impacts on our daily lives. You know, there's a great quote that says, linear algebra bridges the gap between theory and practical implementation of concepts. And SVD is the perfect example of this. It's not just some formula you find in a dusty old textbook. It's a fundamental tool that engineers and data scientists use every single day to build the digital world that we all live in. So to quickly recap the key takeaways here, SVD is an incredibly powerful tool for simplifying data. It is fantastic at finding the most important patterns while filtering out all the noise. And it's this amazing ability that powers everything from data compression and background removal all the way to recommendation engines, making it a true cornerstone of modern machine learning. And that brings us to a final thought. SVD really shows us how much structure and hidden information is just sitting there inside our data if you just know how to look for it. Which kind of leaves us with a question, right? What other secrets are hiding in the data all around us, just waiting for the right tool to come along and unlock them?